All right, all right. Like I said, I love that previous talk. That was excellent. In fact, it dovetails perfect to my section. In fact, I should have like just been like a nice baton handoff. But this conversation is going to be around the future of tech as it relates to data management, analytics, and machine learning. Right? Let's see, make sure if I get this thing correctly. So a little bit about me, and I don't like to talk about myself that much, but I'll tell you a little bit about my background as it dovetails with data management. So I am currently the Chief Technology Strategist at Oracle. I'm responsible for customer solutions architecture, sales enablement, various things, and I focus on engineered system, cloud technologies, virtualization, data management. I am cloud certified both with Oracle as well as AWS. I sit on the cloud curriculum board for a couple of colleges in the Dallas area. And this is my second stint at Oracle. I liked it so much I went back. So I started with Oracle and was there for 18 years in various capacities. And then I started my own company with three other partners and then left and came back to join Oracle just 6 months ago. So I'm back. And part of that process, the last 15 years, I happened to write about 6, 7 books. And there's a little sample of which ones I wrote. But rather than talk more about me, I'll tell you a little bit about why this resonates with me. So my first job out of college, um, I was a data analyst. Had no idea what that was. My degree was in chemistry and physics, so I thought, this is a good way to get into computers because computers are a really hot thing. Right? We're talking about 1989, by the way. So I got into being data analyst, and what it really entailed was looking at data, making sure that the data that we got through FTP, different sources, and make sure that the data was clean and it met the business dictionary, the taxonomy, ontology, things we'll talk about here in a bit. That it wasn't the sexiest, the funnest job in the world. You sat in a little cube and just looked at, spreadsheets and looked at data as they came in. But I always thought the cool guys at the end of the hallway were the coolest ones, which is the storage admins, the network guys, and the DBAs. So somehow, about a year and a half later, I wrangled my way into the storage group. And after working in an organization, I realized I'm doing pretty much the same data management stuff, but at a physical layer. I'm doing lifecycle management of data. I'm doing data assessment, data tiering, proffering up data, from a proximity perspective to end users. And once I left the storage management team, I joined the database administration team, and I became closer to the data even more so because now I'm dealing with business data, dealing with data application developers. So I don't think I ever really felt like I got away from the data aspect as a whole. And now coming full circle, having joined Oracle back again and being focused on data management, I really felt like I did a 360, talking to data analysts, talking to data scientists, and all that. So this is great. It's kind of like a homecoming, if you will, for me. So having said that, let's jump on to the agenda, right? So we're going to be talking about data management and analytics, kind of a historical view, if you will. And we'll talk about which we expect in data management and analytics going forward, and what are the key layers from an operational standpoint. What makes good data good? And then we'll talk about machine learning, its role in analytics, and some of the trends that are coming up. All right, so we'll talk about augmented analytics, machine learning, predictive analytics. Then we'll mention little things about things that I've come across as it relates to best practices considerations if you're doing kicking off machine learning in an enterprise application. Then I kind of end the conversation with jobs, where I see jobs trending. And I did a Google trend just before I got onto this webinar, so I'll kind of share that. Talk about some of the technology and what industries I think are really going to be embracing some of this stuff if they haven't already. And then we'll end it with a summary. Yeah, one of the things I should mention before we jump into this. So when we talk about analytics, it's not really a single entity, right? In reality, it's a collection of technologies. It's user best practices, data mining, it's text mining, clustering, statistics, graph, AI, machine learning, self-service, and visualization. That's what we talk about when we talk about data analytics. So that kind of sets the stage. But I especially like this slide. Whenever I do talks on data management, I always start with this because this is the anchor slide for me. And really, truly, data is king, right? So when we're talking about data, we're talking about unstructured, semi-structured, structured data. It could be invoice data, WebLogic, web data, data that comes from IoT, sensor, social media, even traditional ERP. So when we talk about data, it runs the gamut of all different types, right? So Gartner says information has replaced technology as the central, the most critical asset to be managed by organizations, which dovetails directly into what are things we've been saying for a while, which is, back in the day, computer hardware and peripheral components like printers, servers, and all that stuff, and disk drive storage they were the assets, right? That's what we had on our books. That's what we depreciated. And the data was stuff we threw away. And literally, when I worked in the organization where we had to do data entry, we would truncate and get rid of transactions that are 6 months old. We just didn't want to flood up our storage space, so we got rid of data. And in other cases, we just archived it, put it on worm drives, CD-ROM drives, or even archive storage, because either for compliance or we didn't know what to do with it, right? So data was a second-class citizen in a sense back in the day. So now with the advent of cloud technologies, what's happened is that data is really becoming the true asset, and the cloud, the hardware we talk about as it moves to the cloud, has become subscription based, and that's stuff we really don't care about, right? So data is really the big king. And and what Gartner says, as a result of this, business leaders are must shift to using the value of information for the basis of new planning and funding new models. So really, data has become the world's new currency, right? The ability to harness it, analyze it, and adapt quickly to it is the only way organizations are going to survive and really transform and thrive, right? Every digital transformation, as the previous panel said, it requires access to clean and consistent data. So when we talk about data, it's not just raw data, because raw data is just idle data, but data with good management strategy is really what makes a difference. So like I said, this is the anchor slide, and it kind of sets the tone for the rest of the conversation. So this is a historical view, right? So we started years and years back in data warehousing. And again, this hasn't gone away, right? One of my friends used to say that, man evolved from apes, but apes are still around. They didn't go away. So in the same sense, we still have a lot of this technology, even though we're evolving to other things. So we're going to continue to always have data warehousing and reporting systems. So when we talk about reporting, or basically that means it's organizing data in informational summaries, show quarter after quarter growth or year to date growth by business unit or sales unit. And it's really reporting by KPIs, right? That's what the data warehouses do. And they still do a lot of that. And there's tons of data warehouses still that I support or our organization supports. But what's happened over the last 10, 15 years, we're starting to see this trend towards data mining, data intelligence, and data visualizations with dashboards. And so BI really deals with what happened in the past and how it happened leading up to the present moment, right? It identifies big trends, patterns without digging too much into it, right? It's statistical and analytical functions. It doesn't go into the future, but it really talks about what led up to the current moment. And what the trend has been over the last several years is descriptive analytics. So what happened in the past, predictive analytics with big data analytics, what could happen in the future, right? Some predictive stuff, and prescriptive analytics, which is a whole giant leap, which is stuff that we're really excited about, which talks about, now that you told me that I know what could happen, what can I do about it? Can I improve it if it's a good situation? Can I derail it or stop it if it's a bad thing, right? So prescriptive analytics is really where things are really headed, and that's where rubber meets the road, and that's where the big value comes in. And we haven't really mentioned here, but I want to talk about augmented analytics as it relates to prescriptive analytics, right? Ooh, hope that comes out okay there. So what led us to this point, right? It's a trickle up effect. It's not one of those things where vendors build all these technologies and they said, "Hey, come here," kind of thing. It's the business that drove the new analytics, that they drove the new technology. So modern businesses really demanded modern analytics, and the increasing adoption of advanced analytics tools was really one things that are forcing changes in data management, and that changes in data management required modernization to support advanced analytics. So it's this trickle up effect, right? It didn't happen at once. So one thing led to another, and it trickled up to where we are driving more and better, newer technology. So I'm going to kind of describe this data management and analytics operational view. It's almost a workflow. It truly is, and I'll explain how this relates to machine learning in a bit. But at the top of the stack, we have data architecture. Really, what this entails is understanding where your data originated from. Is it generated from sensor data, and where does it live? Do you want to keep it where it lives, or do you want to bring it in house to do more analysis on it, more cleanup on it? A lot of customers will analyze in place. They'll do storyboarding in place. They'll do analytics in place. Other customers will say, no, we want to bring it in house and do wrangling in house. So that's the first thing they ask is, where's this data being generated? Is it clean? Is it healthy? Is it traceable? And can be pulled in house. The next is data catalog and classification. Here, and this is near and dear to me because this was my first job out of college. As I mentioned, this is a data analyst. And what we did here is that looked at consistent business definitions using business dictionaries, and made sure that the date of birth, DOB, meant date of birth, and birth date meant date of birth as well too. So it's really making sure that the right taxonomy, ontology was being leveraged, rather than having a whole bunch of different columns that meant different things, right? So it's really classifying this data, making sure that it meets your business definitions, and cataloging that data. And the next stage is really data integration, producers and consumers, right? So a lot of the time, data can't be used the way it's positioned, the way it's been generated. Good examples of this is like sys date. Time date stamps can't be, they have to be consistent. If not, they have to be modified. Sometimes you want to do aggregation. This is where we call ETL, extract, transformation, and load, right? We have to do some transformation of the data so it's meaningful, so it's not just raw. So once data integration happens, then there's a data quality aspect of it, really, and this entails the accuracy, the validity, and the completeness. And what we mean here is that is the date, is it correct? We had birth dates which had 2036 on it. Obviously, that's not a great appropriate birth date because it's not valid. So a lot of those things have to be corrected. Sometimes data gets mangled as it comes in. Sometimes columns are empty, and you have to prime those things with min, max, average values, right? So we at the data quality stage, what we do is we give a scoring system to see how good the data is and if it's useful. We don't generally want to throw data away unless it's really, really bad. But in most cases, we can try to mine something out of it, prime the data, clean the data up to a certain extent. Right. And next is data governance and privacy. And I won't talk too much about that because it's pretty self-explanatory. But from a data governance, we really want to make sure that there's integrity, that the security policies are put in place. Right. And then there's oversight into how this data is processed, who gets access to it. So data processes need to be standardized, they need to be optimized to create a compound effect for the organization. Really, the focus is not about generating data, it's doing something valuable with that data, right? And if once you apply this operational process flow through this whole top-down approach, you're going to have what we call data liquidity. And it really data as it becomes data as an asset at that point, right? So why is this stuff important, and where does machine learning and all these other things fit in? So what's happened over the course of 10 years or so, and again, machine learning's been around for a while, and a lot of it's in the back office and genomics, and sometimes even in gaming, it's been there. But with the convergence of algorithmic advances, significant increases in compute power, we're talking about CPU, GPU, and IPU. If you guys aren't, if I've given this presentation before, and eyebrows were raised like, GPUs, isn't that used for gaming? And you're absolutely right. Gaming uses a lot of deep mathematical function, and that's what machine learning is really going to do. It's doing deep algorithmic functions, complex math formulas, floating algebra, floating calculations, and that's why you need GPU. And then there's going to be this new technology coming up called IPU as well. So the compute power has increased. Along with that has been the cloud technologies, right? The advent of Azure, AWS, Oracle clouds. These clouds have made it really easy to adopt this compute power. it's very difficult to get hold and harness on-premise GPUs and really powerful servers. Even if you just want to do a POC, it's too difficult to do and too expensive. So cloud technology has really made that easy to adopt, to do POCs and even do real production type workloads. That coupled with storage capabilities. And what I mean by storage capabilities, it's object store, S3, and getting access to this data, right? So you don't have to have a new EMC frame just to store this sensor data. You can store it in the cloud until you decide what to do with it. This is where the concept of data lakes comes into play. So all these things, this accessibility, the access to compute, access to storage, has really moved AI and machine learning into from the hype category and back office and scientific stuff to the enterprise world, right? And there's a lot of organizations, a lot of companies, Unilever and a bunch of ones that I don't need to mention, have already taken advantage of this stuff, and they've been in the forefront, and they've been adopting this technology for years and years. So technologies such as AI and ML help organizations move towards a prescriptive and augmented analytics, which I mentioned in a previous slide. And by the way, generally I'll use the terms AI and ML interchangeably, but really you're really talking about machine learning here and deep learning in these cases. So ML, what it does is these ML algorithms detect patterns and learn to make predictions and recommendations by processing data and experiences. And it really is experiences, because the server, the system, is really experiencing new data, and rather than giving explicit instructions. So AI and some of these expert systems will have if then else loops to do categorization or make decisions, but that's not what this is. This is not if then else loops. This is machine learning with training data and training it with outcomes, and once that system understands those outcomes, it can make predictive analysis even with seen and unseen data. So these algorithms really adapt in response to new data experiences, and they improve proficiency over time. So it gets better and better. Of course, you have to do some tweaking on the algorithms, but they improve proficiency over time. So at the end state is machine learning really significantly speeds up the processing of uncovering the most valuable information of seen and unseen data. So not only does machine learning do a lot of the heavy lifting of time-consuming effort, but it also uncovers all this data to give you analysis and give you what-if type stuff, right? What-if type scenarios. So what we call machine learning, big data, powerful compute, this is what we consider the holy IT trinity, if you will. And this is what enables this fundamental shift to prescriptive and augmented analytics. So if you guys are familiar with Moneyball, the movie, if you remember what Moneyball did, or even the book was excellent. So it talked about sabermetrics, these statisticians who used sabermetrics to kind of unravel what's behind the scenes of baseball, define how draft picks should be done, if stealing second base is useful or not, and do shifts, and often defensive shifts or not. So what authors Barry Liebert and Megan Beck once said is that machine learning is the Moneyball moment for companies, and it really is. It's really uncovering all this information and making some sense out of this data, out of good data, right? So what we're talking about is systems that can learn from data, learn from experience, and get better at what they do over time. And again, some various companies are at different stages and phases of leveraging AI. Some are way into it. They've already been doing a lot of it with credit card fraud detection, even analysis, on AWS, or I'm sorry, Amazon, doing recommendations. That's all AI and ML based, right? And there's other companies who are just now getting into it in the starting phases. So at the end, when we get AI and ML implemented, this is what we should expect. We should expect these kind of things: correlation, clustering, anomaly detection, and forecasting, things I just mentioned earlier, right? So these are the kind of questions we should be able to ask once the data is good, once machine learning is really harnessed. Is what I'm seeing normal? Is it abnormal? That's anomaly detection. Which users are impacted? Right, that's correlation. What caused this problem? What should I do next? right? It's it's forecasting, clustering. And how do I prevent this from happening in the future, right? That's our prescriptive analysis. And a lot of that has to do with natural language processing. So at the end, when you're using prescriptive analytics, it should come back and tell you, if you do X, Y, Z, this is what it's going to do to improve your bottom line business. It'll come back with English prescriptive outlines of what you need to execute, actionable tasks, actionable items, right? So, but this doesn't come for free, right? So data is really king here. I'm going back to the data theme again. And, we've had conversations with customers where they're trying to do some of this stuff, but they only have unidimensional data sets. They have one set of data, and you can't, when you have one set of data, one set of dimensional data, you get one dimension of output. So, and what we're trying to do here is mash up data. It's great if you can get diverse data, data variety. That really does data enrichment. A good example here is if you can combine spatial data with weathering data, with graph data, you can do some really interesting event management. United States Postal Service does a lot of their routing system based on event management, the graph spatial, as well as the ERP data that goes with it. So, in order to do this really interesting analytics, you got to be able to mash up a variety of data, and that variety of data must come from different places. So a lot of it's through data acquisition. A lot of it is generating the data on your own. A lot of it's purchasing data from third-party sources, right? And I'll talk a little bit about data acquisition here in a minute. So what are the use cases? And I already kind of mentioned it before, right? So some of the things that you're probably already familiar with are fraud detection, right? Looking for outliers, looking for non-normal spending behaviors. So if you live in Iowa and most of your spending over the last 4 months has been primarily in a specific time zip code area, and you start seeing purchases in Paris or Argentina, that's a non-normal spending habit, and you should get alerted on that. So fraud detection, anomaly detection is a key example. Image recognition, TSA person identification as people come through the airports. But one of my favorite ones for image recognition is evaluation of rotten produce. When produce comes through conveyor belt, if you train the system to understand and recognize rotten fruit or damaged fruit, rather than that fruit going out on a pallet and somebody having to recall it or somebody having to do something with it after the fact, you can do in real-time analysis and analytics to say, hey, by the way, I've trained a system to understand what rotten tomatoes look like or bad fruit. It can evaluate that as it's coming off the conveyor belt. So those are some really interesting things. And also what we call virtual assistant and conversational assistants. So you've probably done this when you called Verizon or a couple other service companies where you said, hey, I want to look at my bill. I'm trying to lower my bill. That virtual assistant can decipher through natural language processing the fact that you're talking about not just billing, but a cost analysis, right? It should do input feedback, evaluation based on customer intent. All that is based on machine learning and deep learning. So one of the things I kind of talk here on the right slide here is city planning. I'm really excited about this because I work in public sector. So things like crime mapping, predictive policing are really cool things that you can do with mashed up data, event management data, graphical spatial data, and kind of route police where it's most effective based on events. Let's say there's a rock concert coming around. We know in the past that these events have caused some issues. So rather than having police in an area where they're not needed, you route them to the area where they are needed. So predictive policing, emergency services, reachability. And I think there was a session that was done, I think Tuesday. They're talking about smart cities. Smart cities is all built on machine learning. And one thing I didn't mention is that if you remember this slide 2 slides back here, if I go back one, as it turns out, there are vendors out there who are building machine learning to operationalize this thing up and down the stack. So there are vendors who do machine learning to understand data classification, data catalog. They understand based on some business rules, they can do all this stuff for you. So you don't have to have people like me as fresh out of kid college students doing a data catalog and classification. So machine learning is put in various different aspects, different sectors as well. So what are the key best practices in implementation? This doesn't come for free, right? This is not one of those things where it's a hammer trying to find a nail approach. So it really starts, and this is the conversation I have with customers as well too. It really starts with a senior executive mandate. So senior executives, as I think in the previous panelists mentioned really nicely, is that we're starting to see this emergence of chief data officers, chief governance officers, right? And they need to create data and analytics as a driving force and a culture within the organization. This doesn't come naturally. It has to be driven through data-driven culture. And you need to understand the machine learning projects. Are they value driven? Are they revenue driven, right? Look for good business cases. And always, you always need good data. Data, like I said before, you need access to large volume of diverse data sets. If you have a unidimensional data set, you really can't do much. So you need a large volume of diverse data. Acquiring data as well as data scientists and data engineers. This is where we're going to see the biggest blockade, if you will, in the upcoming years, is a lack of people's skill sets to do the heavy lifting, to do the algorithmic analysis. You need data scientists, you need data engineers. And then data quality integration plans have to be in place. And the last thing here is unified data tier. And the reason why I left it blank is because it's one of those things that hits really, really close to home, because this is what I spend most of my time doing. So what are we talking about with the unified data tier? Here, as I mentioned before, you need to have diverse data sets, and they have to be accessible in some form or fashion, right? So I always talk about this as a developer's delight and an data architect's dilemma. So what's happening in the field, in the industry, is that developers, when they're developing projects, especially with this agile projects, they're developing it in a silo environment, right? They're developing and using tools that they should be, whatever tools they want to use. They're using Rust, JavaScript, Python, C++, .NET, whatever they're using, which is great. But sometimes what happens is, most of the time what happens is they pick a data platform of choice. They'll pick MongoDB because it's a JSON format or BSON format. They'll pick Cassandra because it's a key value-based application. Or they'll pick SQL database such as Oracle, Azure, or cloud databases, which is all good because we want best of breed. But what invariably happens is that developers pick something, they stick with it, and that data becomes very, very siloed. And we don't know if that data even exists. And that's why we say it's a developer's delight, because they get what they want quickly, and they get to develop their applications quickly. But it's a data architect's dilemma, because they don't even know this data even exists. They do not know how to get to that data. Maybe the data is incompatible, right? So this is where a unified data tier technical challenges. By having these siloed environments creates what we call a fragmentation, data fragmentation. And it's really the evil of, or the antithesis of what we want to do with data, good data, right? So I call this the flywheel of fragmentation. So starting with development, right, all the way up to availability, reliability. So with having these siloed data tiers, what it does is that you have to have personnel who are proficient in these proprietary APIs. Maybe they're using different methods of SQL access. A lot of times, from a management perspective, you need operational skill sets that manages that specific data tier. So, for example, the DBAs who manage MongoDB aren't the same ones who manage Cassandra, definitely aren't the ones who manage the Oracle database. So there's operational uniqueness and restrictions that have to happen. And what about data propagation? And we talked about governance. Governance mandates that data has to be consistent across these different tiers. So how do you create consistency if you're doing consistent across diverse sets of data stores? What about security? How do you put in place different security policies across these tiers? And obviously, there's the bigger thing, which is availability and reliability. How do I provide HA for Mongo versus Cassandra versus Oracle, right? There's a lot of fragmentation that happens here. So there's ways around this. Technology always comes around and tries to fix things, which is great, right? Well, sometimes it's a band-aid approach. And what's happened over the years is that smart technologists have built web services, SOA, MuleSoft, and Enterprise Services Bus as an abstraction layer in front of these different data stores. So that basically what we've done here is we fixed the data routing issue so that when a developer wants to insert something into a database, it knows exactly, it goes to where it's supposed to go based on the data routing. But guess what? We still haven't solved the operational problem, right? We still have to manage, we have to keep all this data consistent in the back end. We still have to provide HA for these systems. We've got to still provide security policies for all these systems in the back end. So we solved one big data routing issue, but we left a bunch of others. So what we're starting to see in the industry is this concept of a converged database, a multi-model or converged database. That the terms are sometimes used synonymously. But what a multi-model or converged database is supposed to solve is it's supposed to solve radically simplified data management, and it should be able to support various different types of data types: relational, JSON, XML, graph, spatial, OLAP, and even text. And it should be able to support various types of workloads, right? Whether it's transactional, analytics, in-memory, IoT, streaming, even blockchain. But at the end of the day, it's also got to do the most important thing. It's got to simplify the operational database support in the back end. And companies like Oracle, Azure, a bunch of other out there are starting to become vanguards in this space to provide this multi-model converged database solution, right? So that's the first forefront we're saying. The next thing that we're starting to see an evolution is augmented analytics. And what augmented analytics is it really uses statistical, which is machine learning, and linguistic, which is natural language processing capabilities to improve data management even further, drives the enterprise search capabilities. If you remember that slide that I had, that data operational stuff from data architecture, data classification, data augmentics, along with what we're calling auto ML, auto machine learning, is going to streamline that whole process, right? We're still in the midst of, into making this stuff solid, but this is what you're going to see in the next year, 2 years, is be able to streamline an entire data pipeline process. What that does is accelerates the data preparation, discovery process, assists in the whole pipeline. And the reason why we need to do this is because of the problem I mentioned earlier, which is the dearth or the lack of acquisition of data, as well as acquisition of skill sets. Data scientists are really, really hard to come by. So what augmented analytics, along with auto ML, is going to do is going to simplify that to a certain extent. And the most important thing it's going to do, it's going to democratize data analytics for less business savvy users. And you're going to start hearing this term citizen data scientist or business casual data scientist. By the way, I coined that term, business casual scientist. So spread it. So this is what it's really catered to, is that you don't necessarily need to have these PhD business scientists. You probably want a handful, but you don't need 10, 20, or 1,000 of them, right? And augmented analytics is supposed to save on that in that space. So what this is going to do is enable faster adoption of actionable items. When we talk about prescriptive analytics, it's going to be able to bring to me forth the actionable insights. That's what, tell me what I should do in a year, 2 years, 4 years, 5 years from now, right? And NLP, the natural language processing, we're already seeing some of that with Siri, Alexa, and Google. Hey Google, right? You're starting to see this analytics already happening in place. So once that's done, this is a slide I just threw out there, but this is what you're going to start seeing as this pervasiveness of AI. We had the semantic layer, we had the visual-based data layer, and now we're starting to see this augmented analytics, which is ML-led, augmented and automated, dynamic, and open data and analysis. This is where we talk about the citizen data scientist. So I'm going to start winding it down and talk about jobs, opportunities, and industry. So what just before I got onto this webinar, if you guys have ever used Google Trends, it's awesome. I use it every once in a while if I want to see trending activity on certain topics. So what I trended here is a BI analyst, machine learning data scientist, and DBA. So before I get onto that, with the things on the left, those where I see the biggest jobs trend coming up. I see trends with data scientists, machine learning engineers, statisticians, data and analytics managers, data engineers, as well as DBAs and data administrators. But if you look at this chart below, the red is your BI analyst, your BI engineers. They're pretty steady, right? This is over the course of 15 years, by the way. So you see the BI analyst has been pretty steady over the years. But look at the machine learning, your data scientists. That thing has skyrocketed from about 2014 or so all the way up to now. It's really jumped. I don't know why there's a drop there at the end. Maybe that could be for COVID, but that's what we're really seeing is that uplift of that career. So what industries are we really seeing this uplift and adoption? We've already seen it in other areas that I mentioned before, but agriculture, healthcare, aviation, and cybersecurity, right? For aviation, companies produce massive amounts of data. And this data is used by them to improve services like customer experience, fixed flight schedules, safety data, route optimization, preventative maintenance. All these things are really being leveraged in aviation if it hasn't already. And in the cybersecurity space, cybersecurity has seen a recent surge with various companies leveling up to security systems with increasing malware, predictive analytics with malware. Data engineers demand with increase of companies trying to find anomaly, intrusion detection use cases. So this is where we're starting to see a big trend in these four spaces. And with that, I'm going to end with my summary and to kind of rehash what we talked about. I know I threw a lot of information at you guys. So in summary, really, data analytics and machine learning is moving from hype to mainstream, which I think I hopefully established. But the thing is this, AI and ML are transformative technologies that require transformative approaches. So you can't just do business as usual. I call this the high caloric effort, right? I mean, it takes a high calorie, a lot of effort to even reorganize your environment, reorganize your structure of your company to be able to do some of this analytics. You can't do business as usual with this kind of thing. So build a data-driven ecosystem and foundation. Data analytics should not be siloed. It shouldn't be a one-time use case, right? So we need to understand the form of advanced analytics. I'm not saying machine learning should be used in every case. It's not the hammer for every nail, right? So each analytics or each application requires distinct data requirements. There's self-service analytics, which works best with subsets of semi-structured data and business metadata. But if you're talking about mining and statistics with Excel or massive amounts of volume of data, that should be done differently, right? And finally, if I can't harp on this enough, it's really unified data tier. Machine learning, deep learning works best with a ton of data, ton of diverse data. So, and that can only be accomplished with a unified data tier, which means data diversity, right? And that entails having data as an asset. Again, as I mentioned before, we're going to see a huge uptick on job growth opportunities in AI and ML, as well as analytics. And with that, I'm going to turn it back to Mary.
That was great. Thank you so much, Nitin. We're actually right past 6:40, or Central. We're on Central, 7:40 for all of y'all on Eastern. I am actually going to drop the Q&A that came through for you in the chat and just send it open to everyone so they can see if you have a couple minutes to respond via chat.
Sure.
But I know we've got our next speaker waiting and ready to jump on. Truly appreciate your time and your wisdom. This was beyond insightful. And we'll be sure to share the recording with folks who missed, and hope to see you again soon. Stay safe.
Yeah, thank you guys. Appreciate it. Good luck.
Thanks.